Hello again. In this video, we're going to discuss parametric descriptions of solution sets. We're going to use parametric descriptions when a system has more than one answer, has many answers, has infinite answers. Because if you remember from my first video, systems have three types of solution. There could either be one solution, exactly one solution. There could be no solutions, inconsistent, or there can be an infinite number of solutions. So when a system has more than one solution, it's going to end up having an infinite number of solutions. Here's a little snippet from the book right under parametric descriptions. And it says, whenever a system is consistent and has free variables, the solution set has many parametric descriptions, which you'll see is going to mean that the solution set has an infinite number of solutions. So let's consider the system here. X1 plus 5x2 equals 21, and x2 plus x3 equals 4. If I wrote this in an augmented matrix, here is the augmented matrix with columns 1, 0, 5, 1, 0, 1, 21, 4. This matrix is in echelon form, but it is not in reduced echelon form. It's in echelon form because here is our first non-zero entry in our first row, and here is our first non-entry 0 in our second row, which is, by the way, to the right of the first row. And there is a 0 below each of these pivots. It's not in reduced. It does have ones in the first non-entry, so that's good, but it needs a 0 where this 5 here is in the second row. We need a 0 there because we need each pivot to be the only non-zero number in that column, if you remember from our last video. So let's go ahead and do that. To do that, I'm going to take -5 times the second row, add to the first row, and put into the first row. By the way, this is called backward phase. When you're getting something in echelon form, it's called forward phase, and getting it in reduced echelon form is getting it in backward phase. So I'm going to leave my second row alone, and the first row is going to become 1, 0, -5, and 1. Again, to see this, you're going to put a -5 here, multiply, add, multiply, add, multiply, add, and finally multiply. -20 plus 21 is indeed 1. So we're going to consider these to be our pivots. Those are called our basic variables. This is going to be called our free variable. If you remember, the first column represents x1, the second x2, and the third x3. So x3 is going to be considered free. So you can see, because of this, there's going to be an infinite number of solutions. So we can now solve for x2 in terms of x3. From the second row, we know that x2 plus x3 better equal 4. So I'm just going to solve for x2 here. And that's going to be the solution for that. And then I'm going to do the same thing for x1, the first row, x1 minus 5x3. Again, it's in terms of x3. So x1 equals 5x3 plus 1 for solving for x1. And you can see x3 is free. We found x1 and x2 in terms of x3. So going back to our little snippet, it said, if you remember, when a system is consistent and has free variables, the solution set has many parametric descriptions. It has an infinite number of solutions. And you can see that because if x3 is free, then it could be anything. It could be 1, it could be 2, it could be 3. And depending on what x3 is, there will be another solution for x1 and x2. And this is how our book will always describe the solution set. Some books actually choose a variable like, say, t for x3. In a couple places in the book you will see this. So therefore x2 equals negative t plus 4, and x1 is 5t plus 1, and then that really shows you that it could be anything. Now we can write it as a solution set, x1, x2, and then x3 is there, such that t is any real number. And you can really see now, if t is any real number, there's an infinite number of solutions. So now let's go to our second paragraph in our little snippet. We could treat x2 as a parameter, it says. So we could have treated x2 instead of x3 as a parameter and solve for x1 and x3 in terms of x2. And by the way, that would have been an accurate description of our solution set, but we're not going to do that. It says here, however, to be consistent, we make the arbitrary convention of always using the free variable, if you can see here, x3 was our free variable, as the parameter for describing a solution set. So we're going to parameterize x3 because x3 was our free variable. And by the way, the answer section, the answers in the back of the book of this text also reflects this convention. So the answers in the back of the book will look like this. So again, the variables corresponding to pivot columns in a matrix are called the basic variables. So x1 and x2 are called the basic variables, and the other variables are called the free variables. In this case, x3 is our free variable. A parametric description or parametric descriptions are solution sets in which the free variables act as the parameters. Let's visualize this in a three-dimensional space by solving the system. So the first thing I'm going to do is write this as an augmented matrix. Now I'm going to do the forward phase and write this in echelon form. So we have a pivot. We want to get 2 zeros below it. So I took -2 times row 2, added 2, and put into row 2. And you can see I did this here. I left row 1 alone. And if you put a -2 here, you can see that this becomes a 0. The next one is a 1, a -1, and then a -4. Doing the same thing for row 3. Notice I can get the 2 zeros here in one step. I'm just going to take 1 times row 1, add it to row 3. So essentially I'm just adding them together. In my second row, this is my first non-zero entry. So I'm going to get a 0 below that second pivot by taking 2 times row 2, adding to row 3, and putting into row 3 to get a row of zeros. You can see that by putting a 2 right here, and you will get a 0 in all 3 or 4 columns, which describes our 3 cases. If we would have gotten a number here, then there would have been one solution. If we got a 0 here and a number here, then there would have been no solutions. But getting a 0 in both means that there's an infinite number of solutions because x3 is free. If I try to write it like this and not get it in reduced echelon form, it's going to be a little bit ugly because you would take x2, that's fine, but then on this one is going to be in terms of x2 and x3. So you would have to substitute your answer from your second row and put it into your first row. So that is why when I have an infinite number of solutions, it's always easiest to put this in reduced echelon form. So I'm going to put it in reduced echelon form, meaning this pivot, all I need to do is get a 0 above that second column. So I took I'm going to take 1 times row 2, add it to row 1, and put it into row 1. And you can see something interesting happens here. I'm going to just add these, and you'll see that you get a 1. Both of these become 0, and then this is a negative 1. So we actually have a value for x1. x1 is negative 1. Now I'm just going to call it x here, because if you remember, this is our x1, x2, and x3. They let this just be x, y, and z. So we know that x is negative 1. And the variable that's free is z. Z is free. And then we can find the y by saying, so I'm just going to call this instead x, y, and z. I know I wrote x1, x2, and x3 here, but I forgot. So we have here y minus z equals negative 4. So y would equal, in terms of that free variable, z minus 4. So we have the solution set. This is how the book will write it, but if you wanted to write it as negative 1, x is always negative 1, and then y is z minus 4, and z is our free. Z is like our t, where z is any real number. And in math, sometimes I'm going to write like this time. This time, z is an element. That means element of the real numbers. This double r here is the real numbers. And here's a picture of what that looks like. You can see that we do have 3 equations and 3 unknowns, but since it looks like 3 planes are intersecting along this one line, so x is always negative 1, but that y value is always going to be z minus 4. I got this drawing using a 3D, online 3D graphing calculator, and I plugged in my 3 equations here. And here it is here, just so I can show you that a little bit more clearly. There it is. It's an infinite number of solutions, even with a 3 by 3. And that happened because we got a row of zeros here. So let's look at another example that's in the book. You can see that this is in echelon form. There's a 1. It's our first pivot. Our second row, this is the first non-zero entry, and there's a 0 below it, and it's to the right of the one above, and the same with this one. There's no 0 above it, but it is our last row. And this is an augmented matrix, so I'm going to add a line here. Okay, when we do backwards, a reduced echelon form, backwards phase, we always need to make sure that we get the zeros in the last column. You cannot get a 0 in this third column here first. You got to do the last column. That's why it's called backwards phase. So let's go ahead and do that. So I took row 3, added it to row 2, and put it into row 2. At the same time, I'm going to get a 0 in this negative 2 spot by taking 2 times row 3, added to row 1, and put it into row 1. And you can see when you do that, it doesn't affect any change except for where we want it. That's why you want to go backwards. And then now, I could get a 1 here first. I don't need to. If you don't want to put it in reduced echelon form, because it happens to be a 2, you can go ahead and do that. But since the second row is all divisible by 2, I went ahead and did that. So I just took the second row and I divided everything by 2, did not change row 1 or row 3. Now I'm going to go backwards and use that second column because I've already did that one, and get a 0 in this 2 position in the third column. So I'm going to take negative 2 times row 2, add it to row 1, and put it into row 1. I'm going to put a 2 there. And you can see when we do this, it does not change the first 2, and it changes this one. This was supposed to be a negative. And so we have a 8 here. Negative 5 is 3. And the next one, it does not change. Now, if that was, you did not do this first, that would change that and would not be good. And oh, by the way, that's a 0 as well. That's interesting. Pivots here, here, and here. Now we have multiple free variables. So here's the solution. x2 is free, x5 is free, x1 I got from the first row, x3 I got from the second row, and x5 is 7.